Question number 7. A particular a particular piece of music was played by 91 pianists, and each pianist the number of incorrect notes was recorded. The results are summarized in the table. So number of incorrect notes is given as this. Class intervals. So let's just have the class interval. This is 5, this is 5, this is 10, this is 20, and this is 30. So that means they have unequal class intervals. Whenever they have unequal class intervals, we have to draw frequency density on the y-axis. So frequency density is taken into consideration, and we have the frequency density formula as frequency over class width. So these are the corresponding frequencies for these. So if we calculate this frequency density, which is equal to frequency divided by class width, we get their corresponding frequency densities as 2, which is frequency over class width. 10 divided by 5 is 2. Then 5 divided by 5, that's 1. Then 26 divided by 10, that's 2.6. 32 divided by 20, that's 1.6. 18 divided by 30, that's 0.6. So on your y-axis, like it shows over here, you have your frequency density on the graph. That's what I've done. And on your y-axis, on your y-axis, you have your frequency density. This is the y-axis. You have your frequency density on the y-axis. On your x-axis, you have the class intervals. But one thing to note for the class intervals is there's a gap between the upper limit and the lower limit of the class intervals. So this is 5 and this is 6. They have to be the same. So once we are drawing a histogram, there shouldn't be a gap between the two bars. You see the bars are joined together. So for this, we have to take 0.5. We add 0.5 to the upper class limit over here. This is going to become 5.5. We subtract 0.5 from the lower class limit from each class interval. So this is going to become 5.5. So this 6 minus 0.5 becomes 5.5. 5 plus 0.5 becomes 5.5. So they join and they become 1 then. So the gaps between each class interval is finished in that way. And we have something looking like this. So we have 0.5, then we have 10.5, 20.5, 30.5. This is what I've done. I've taken gaps of 10, 2 blocks to represent gap of 10. This is one block to represent a gap of 10. So that's 1 block, that's 1 block, that's 1, that's 1. And then this is 50, 60, 70.5. So 40.5, 50.5. This is 60.5, and you have 70.5 as the final one. So now you have to draw the first one. So that's remember, this is, you subtract 0.5 from the first one. So we'll have the first class interval 1 to 5 written as 0.5 to 5.5. And this class interval starts from 0.5, goes up to 5.5, and frequency density is of 2. So 0.5 to 5.5 right over here. So it starts from here, finishes off over here at 5.5 and goes up till 2. So this is where the first bar we're getting, over here. The second one is also of a width of 5. So this is going to be from 6. This is from 6 to 10. So this is going to be from 5.5 to 10.5. This is going to have a frequency density of 1. So 5.5 to 10.5 with a frequency density of 1. So that can be seen right over here. That's what we have. And similarly, we do the same for the rest of them, and we get a histogram looking like this. Now, if we move on to the next part C, or part B of the question. It says, state which class interval contains the lower quartile and which class interval contains the upper quartile. Hence, find the greatest possible value for the interquartile range. So we have 91 people over here in the distribution that's given to us. This is given for 91 people. Now we know that 91 is an odd number. So if we have to find halfway between 91, how many values will we have over here? How many will we have over here? And what is our going to be our center value? So the center value over here would be, we'll have 45 over here on our left, 45 on our right, and 46th value is going to be the center value, which is going to be Q2, the median. But it's not asking for the median. So now we know we have first half of the data as 45 values. Now 45 is also an odd number. And if we divide 45 further, we get 22 values over here, 22 values over here, and 23rd value will be our Q1. So Q1 is going to be our 23rd value. So we go back and we see where are we getting the 23rd value. So 10 plus 5, that's 15. 15 plus 26 is definitely going to give us where our 23rd value is going to lie, because we have 10 values over here, plus 5, that's 15 values, and then plus 15, and we need the 23rd value. So plus 26, so that means the 23rd value, which is Q1, the lower quartile, lies in the interval of 11 to 20. Similarly, we do the same for this. So we have the second half of the data as 45 values. So we have this as 22 and 22, and this is going to be the 23rd value over here. And this is the 46th value. Remember, this is 46th, which is Q2. So 46 plus 22. So 46 plus 22, which is going to be 68. 68. Yeah, so 68. So 69th value over here. So that's 46th value was our Q2. And we are adding more 22 more values from here, so that gives us 68 values before we reach Q3. So Q3 is going to be our 69th value. And where is that 69th value going to fall? We add them up and we see where we are getting the 69th value as. If I can clear this all up, since we already have done this. So where are we getting this value as the 69th value? So we have 10 plus 5 plus 26. So 10 plus 5 plus 26, that's 41, plus 32, that's 73. So that means our Q3, which is the 69th value, and this was the 23rd value. So it falls in this range. The 69th value falls in the range of 21 is to 40. So if you go back over here, it says state in which interval contains the lower quartile. So the lower quartile in which class interval. So in which class interval is the lower quartile? The lower quartile is from 11 to 20. That's from 11 to 20. The upper quartile is from 21 to 40. So the upper quartile is from 21 to 40. Now it's asking us to hence find the greatest possible value of the interquartile range. The interquartile range greatest value will be if we have one value on the extreme value of the upper quartile and we have an extreme value on the lower quartile. So that's going to give us the greatest possible difference between the two values, because IQR is Q3 minus Q1. If you need the greatest possible difference, so you look for the maximum, the highest over here, which is 40 in this class interval. You look for the minimum in which Q1 lies. Now Q1 lies from 11 to 20. We don't know which value it is. So it may be 11, it may be 12th, 13th, or maybe the 20th. But since we are looking for the greatest possible difference, we go for the lowest one over here in the lower quartile, the highest over here in the higher quartile. So that's 11 minus 40 minus 11, and that gives us 29. 29 is the answer to this question, to this part. Part C, calculate an estimate for the mean number of incorrect nodes. So the mean number of incorrect nodes is just going to be x bar, which is going to be sigma x over sigma. So in this is fx, sigma fx upon sigma f. And x is going to be all the midpoints. So we have to calculate all the midpoints of our class intervals. So we do that over here since we have the table over here. So if we can quickly find the mid values of all the class intervals. So 1 to 5, we get the midpoint as 3. So the mid value over here is 3. From 6 to 10, the mid value will be 8, halfway between. So 6 plus 10. So 1 plus 5 is that's 6. 6 divided by 2 is 3. 6 plus 10 is 16. 16 divided by 2 is 8. And 11 plus 20, that's 21. 20, that's 31. 31 divided by 2, that's 15.5. Similarly, we do the same for this, 40 plus 21, and then divided by 2. So that's going to give us 30.5. This is 41 plus 70 divided by 2, so that's going to give us 55.5. So these are all the midpoints, the mid values for the x. Now, our formula for this, for the mean, is sigma fx divided by sigma f. So sigma fx, sigma fx. So f is the frequency multiplied with the x value. Remember, this is the frequency, it's not the frequency density. So we multiply the frequency. So it's 3, the x value multiplied by its frequency, that's 10. So I'll just do it over here. It's convenient so I can see the table and write down the values instead of doing this on the next page. So that's now I have this as 8 multiplied by 8, multiply this by 5. And then I have plus 15.5. I had this 15.5 multiplied by 26 plus 30.5 multiplied by 32. So I've just done this 15.5 multiplied by 26. That's right over here. And then I've moved on to 30.5 multiplied by its frequency, that's 32. Then I'll do 55.5 multiplied by its frequency, that's 18. So plus 55.5 multiplied by its frequency, that's 18. And whatever the total I get, all of that has to be divided by sigma f. And remember, sigma f was given as 91 because this data was given for 91 people. So if we add them all up, we get 2448 divided by 91. That's sigma f. And we get the mean for this distribution as 26.9 vector 3 SF. And that's our answer. And this was the last part of the last question for this paper. So this is also done.